This looks like an interesting problem. It looks like we have a patient receiving some medication in the form of an IV drip and over a period of time, and we need to evaluate this and express it as a linear equation. So let's go ahead and highlight the important information here and read through the problem. A nurse sets up an IV drip for a patient. After 3 hours, the patient has received 426 centimeters cubed. What are those? Those are cc's, aren't they? Cubic centimeters of the IV solution, and after 5 hours they've received 640 cc's. Assuming a linear relationship between cubic centimeters and hours, and recall that a linear relationship just means when we plot this it's going to be a straight line, no curve, no step pattern, just a straight line. So a linear relationship between cc's and hours, we want to find an equation that represents this relationship. Write your answer in the form y equals mx plus b. And there's a hint here. It says let the hours represent the x values and let the cubic centimeters represent the y values. So in a problem like this, probably a good idea to start with an xy axis. So let's go ahead and draw that in and then use our hint here to help us figure out how to label each of the axes. The hint says let hours represent the x values. And how many hours do we need? We've got a 3 hours, 5 hours is our maximum. So let's go ahead and label our graph with hours up to maybe 6 here. And then let the cubic centimeters represent the y values. Cubic centimeters, our largest value is 640, so maybe we'll go up to 700 here. And let's go ahead and label our cc's on the y-axis. And at this point, we're probably ready to plot our points. We only have 2 points to plot here for this problem. We've got 1 point after 3 hours, the patient has received 426 cc's. So we come over to 3 hours and we come up to 426, and we can plot a point that's maybe right about there. And then after 5 hours, they've received 640 cc's. So let's come over to 5 hours and plot 640 cc's, maybe right about there. And then let's go ahead and draw a line that connects these 2 points. We might want to go ahead and label these 2 points. We've got one that can be represented by its x and y values in order, an ordered pair. The x value of this point is 5, and the y value is 640. And the x value of the other point is 3, and the y value is 426. And we can call this point 2 and point 1, which would give us an x2 and a y2 for point 2, and an x1 and a y1 for point 1. So let's go ahead and recall that we want to solve this in the form y equals mx plus b, the equation of a line. Recall too that m in this equation form represents the slope of the line, and b represents the y-intercept of this line. The y value on this line when the line passes through the y-axis, where the value of x is 0. So let's begin with slope up here. Recall too that slope can be calculated. It's known as the change in y over the change in x, or we can use y2, the y value at point 2, minus the y value at point 1, over, divided by, the x value at point 2 minus the x value at point 1. So let's go ahead and plug those values in. We have at point 2, our y value is 640. At point 1, our y value is 426. And at point 2, our x value is 5. And at point 1, our x value is 3. If we do that math, we end up with a value of 214 for our change in y, and a value of 2 for our change in x, and if we reduce that improper fraction to a whole number, it's going to come out to 107, and that is our slope. That is our m value, 107. Let's think next about our y-intercept. It looks on our graph like it's pretty close to 100, but we want to be very accurate about this. In order to solve for our y-intercept, what can we do? We can plug our slope into this original equation here. We have y equals 107. We know our slope now is 107, x plus b. And now we can take any point on this line. We only know the exact values of 2 points, but we can take our y value and our x value and plug those in and solve for b. So let's use this first point here. We're going to use our y value of 426, and we're going to say that that is equal to 107 times our x value there, which is 3, plus b. If we continue, we get 426 is equal to 321 plus b. We subtract 321 from both sides, and we're left with b is equal to 105. So now we have our b value, our y-intercept value, we have our slope. So our last step is to put it all together and come up here and indicate that this line can be represented by the equation y equals our slope 107 times x plus our y-intercept, our b value of 105. So there is the solution to this problem. So what does this equation tell us? Well, it tells us that the slope represents the amount of medication that's administered every single hour. A slope of 107 would mean that in a 1-hour period, this patient is receiving 107 cc's of medication. The y-intercept there of 105 is a little puzzling, but we might interpret that in this instance as, that's our starting point. That's at 0 hour. And so that might indicate that the instruction that this nurse received was to administer an initial dose of 105 cubic centimeters, 105 cc's, maybe to get a little boost on an infection if this is an antibiotic, or to get a little more medication into the patient up front for some reason, and then set the drip at 107 cc's per hour thereafter. So that's what this equation in the form of y equals mx plus b would indicate in this type of a situation. I hope that's helpful.